When people don't understand how a particular tech works, the first response is fear and chaos. Half knowledge has always been a plague for humanity. It gets on my nerves when I see the entire internet going on a rampage over how AI will steal creative jobs. I've seen this from tech entrepreneurs, designers, and techies. The only people I've seen who are unfazed by this are people who actually understand their craft. Half knowledge is a buzzkill, and in a world of information overload, a clickbaity news headline is more than enough to cause chaos. Moreover, you get better clicks on YouTube thumbnails and news headlines that say AI will take away your jobs. This is a news article summarized by InShorts. Lack of research and poor writing. Even the words used are clickbaity. DALL-E 2 has predicted what the last selfie taken on Earth will look like. Bullshit. I myself am not an expert in AI, but I think it's better to do research and search for the truth than blindly joining the bandwagon of protest. Because hey, sitting and talking about how AI will destroy lives is more fun than actually doing your own research. Let's deep dive into how DALL-E works. More specifically, the latest version of DALL-E, DALL-E 2. The generator's name was coined after combining the name of the artist Salvador Dali and the robot Wall-E from the Pixar movie. DALL-E 2 takes text as an input and produces images as its output. But all of this isn't done in one go. Rather, DALL-E 2 uses a variety of techniques that have been iteratively improved over time. These techniques are stacked on top of each other like Lego blocks to compose the full model. To understand DALL-E, we need to understand what each part of these blocks does. One of the most important building blocks in DALL-E 2's architecture is CLIP. CLIP stands for Contrastive Language Image Pre-training. This is the main bridge between text and images. In simple words, CLIP represents the idea that language can act as an intermediate for teaching computers how one image is different from the other. For understanding CLIP better, we need to understand the shortcomings of previous computer vision systems. Before CLIP, neural methods for computer vision were meant to collect massive data sets of images, then hand each image one by one into categories to teach the AI model what each image meant. Kind of like showing a picture to a baby and telling them what it is. What makes CLIP so powerful is the idea to not train these models to just identify categories, but rather to identify the caption of each image from a list of random captions. This allows the model to use simple language to understand the difference between an old man and an old man smoking a cigar. CLIP is able to generate a dictionary of images and text and create a kind of vector space. It understands what text corresponds to what image. In a way, this allows it to translate a text into an image. But converting individual text to individual images is just a part of what DALL-E does. What's more important is that it needs to understand language like how we humans do. When words are clubbed together to create a prompt, it needs to understand the whole context of the prompt to convert it into an image that is close to how we described it. This is where the second building block of DALL-E comes in, the diffusion model. I got this example from an article written by Daniel Fain on Medium that explains diffusion models better. Imagine a fully solved Rubik's Cube. Now you can randomly twist it again and again until the Rubik's Cube becomes completely scrambled. Now, how would you solve it back if you don't remember how you reached the final scrambled result? You could solve it one step at a time. You keep twisting the cube based on what face gets you closer to having the same colors on one side. Basically, you're going from a state of disorder to a state of less disorder. This is the fundamentals of how a diffusion model is created. You take a picture, scramble the pixels until all you have left is pure noise. Then you train the AI model one step at a time to rearrange the pixels until you are back to the original image, or at least something that makes more sense. Once such a model is trained, you have something that can take randomness and create sensible information from it. By showing the model newer and newer random samples, we can get newer images. Of course, the maths behind this is much more complicated, but this is how DALL-E 2 works in a nutshell. Now, DALL-E 2 isn't perfect. In fact, far from it. As magical as it looks, it has some major limitations. Firstly, it is not good at generating images with coherent text. For example, if you give a prompt a sign that says deep learning, you are going to get some gibberish. Use AI as a tool, not as an enemy. Today's art generation tools are far from perfect to actually use it for commercial projects. The research looks promising, but we are decades far from perfection. As a designer, 80% of your time goes in finding the right assets for your project or recreating them from scratch. DALL-E 2 reduces that process to just minutes by being able to generate assets for you as you type them. It might be frustrating to get a decent result, but it reduces design time by huge magnitudes. The whole point of hiring a designer or artist in the commercial space is to control the nuances of a piece of work. Once an image is generated with DALL-E, controlling the minute details is virtually impossible. You could go on and on generating variations, only to realize that an artist could work on it better. Fear will not take you anywhere, because at the end of the day, in the commercial world, DALL-E 2 is not going to replace your designer or artist. In fact, tools like DALL-E 2 has created newer jobs and marketplaces just to get the right prompts to express what you want to the art generator. Here's what OpenAL, the foundation behind DALL-E 2, has to say about it. Our hope is that DALL-E 2 will empower people to express themselves creatively. DALL-E 2 also helps us understand how advanced AI systems see and understand our world, which is critical to our mission of creating AI that benefits humanity. Lastly, it is important to understand what art is. Art is a medium to peek into a human psyche soul mind. It cannot be reduced down to replicated images. Picasso or Andy Warhol's work isn't in the Hall of Fame because it is impossible to replicate them. In fact, most of Andy Warhol's work can be replicated by a decent artist. The true genius behind an artist is to create new art forms, an art form that can truly express. The difficulty of replication was never a threat to the world of art. Only people who don't understand art actually go around making a fuss about it. Art isn't a byproduct of reverse-engineered images. If you've reached this far on this post, you'd understand that AI is far from being able to actually be created. Creativity comes with experience, ideas, and inspiration. Maybe at some point when AI reaches the point of singularity, we might see a whole new picture, but in reality, we are nowhere close to it. The rate of advancements in research may fool you into thinking that a sentient AI is super close, but the real question is whether is it truly sentient or mimicking sentience. That was my 50 cents on AI replacing creative jobs. If you found this video insightful, do share it. And if you have counter views, would love to discuss them in the comments.